This is the TBN Total Base Number Webinar. We're going to cover ASTM D2896-21 and ASTM D4739-17. My name is Hank Levi, and I'm here with Charlie Williams. Say hi, Charlie. Charlie's been around. He's a guru in titration and a lot of other things, lab rat. So between Charlie and myself today, we're excited to kind of go over this application. It's pretty popular. This is not a formal presentation. In fact, I don't think any of our webinars, Charlie, are going to be formal in any way. We like to look at these as very informal, back and forth chatting. We might even go back a slide or forward a slide. So let's just jump into our first slide here. Oh, by the way, we have 10 slides today. So we're going to try to finish this up in 45 minutes to 55 minutes, something like that. 10 slides. We're going to go over the TBN base number. We're going to talk about what is it. We're going to talk about what you need to do TBN on a titrator. We're going to talk about some of the things that go into the calculation. We're going to talk about best practices, things to look out for, and just some nice general information. So anyway, but the first thing, we're talking about two ASTM numbers, ASTM D2896 and ASTM D4739. Those are the two popular ones, -21, -17, respectively. Those are the two that are out there that people are using, and we're going to get into why is there two ASTM numbers for TBN total base number. But for right now, what I was hoping to find out is from our audience, are you using one or the other or both or none of these? So that's our first question of the day. And I've been talking for a few minutes, so I'm going to let that go for a few more seconds so our people who are watching can let us know. I have no idea if it's tabulating yet, but let's just go ahead and see what we've got here. Okay, there we have it. Looks like 60% is using both methods, and 40% says none of the above. So, and maybe I clicked on this too soon, and maybe people are still voting, but nobody, it looks like, is doing one by itself. I find that interesting. I know some of you out there, we have done some on-site service training, annual PM, and we've done some on-site training with you. And so, you know, we've had, some of this is review for you, but we know that two methods are being used, two ASTM methods are being used. And I think, Charlie, you might agree, I don't know, sometimes it's like, are you using both of them because you have to or because you want to? Meaning, sometimes the specification just says you got to use both methods, and that's the answer.
If you're writing the specification, too, that matters. Or, you know, if you're doing, I guess, used oil testing,
yeah, you
would use.
Yeah, we're going to get into that. There are some pros and cons to each of the methods, and I really don't know beyond why the specification might be one or the other than the fact that there's a pro to it and a con to it. But sometimes the specification just says do them both, right? Yeah. All right. So anyway, good to know, because we're gonna build off of that. So let's go ahead to our first slide. A little background about total base number. What is it? Okay. So basically, acidic contamination of lubricating oils is a result of oxidation and thermal stress. That's kind of what's going on. But more importantly, the presence of these acids contribute greatly to the degradation of a lubricant, right? These undesirable byproducts increase machine wear by decreasing the performance of the lubricant. So bad things are happening. This next bullet point, though, is important. Reserve alkalinity is the term used as a measurement of an oil's ability to tolerate contamination by acids. It is comprised of various alkaline additives such as detergents, dispersants, and antioxidants, serving to neutralize acidic contaminants. That's really, I think, one of the more important points of this whole thing, isn't it, Charlie? I mean, can you talk about the detergents, the dispersants, and the antioxidants?
Well, they're all, of course, they're all alkaline components to it. They're added. They each have their their own little job to do. Detergents try to keep they're a surfactant, so
Yeah.
they keep the dirt off of the metal. Dispersants keep the contaminants from glomming up and causing more problems. Then, of course, antioxidants try to keep the acidic components from being formed in the first place.
So to say it another way, we want these things in the oil. Would you say that, or we
Yes.
don't want?
Oh, yeah. They're purposely added,
Right.
and they make up uh, part of that reserve alkalinity.
And so we're measuring some of this, I guess. We're looking to see if these things are present to
Yes.
that kind of gives us the health of that oil.
Yes.
Okay.
In particularly the 4739 method.
Okay.
Picks
Okay.
these up.
Okay. So yeah, we're going to get into the two methods. Right now we're kind of talking in general here. So yes, the most common technique for evaluating an oil's ability to neutralize acids is to measure the total base number by potentiometric titration. So that's what that's about. And the two most generally accepted methods for measuring reserve alkalinity is ASTM 2896 and ASTM D4739. -21-17 respectively. So that's some of the background. I haven't seen any questions pop up, but that's what we're talking about. Measuring TBN is important to understanding, I guess, the health of the oil or the ability for it to stay healthy over time. Would you say that? Would that be
Yes.
a way to say it? Okay. I like it. I got that right. Okay, let's go and talk about the method calculation. I'm just thinking out loud here. If you want to talk about the method calculation, I guess we did first. We do want to talk about the method. Yes, we did.
Yeah.
Okay. Yeah, we do. So TBN is measured in milligrams KOH per gram. Okay. And that is equal to, you can see the calculation here, the endpoint minus the blank times the titrant factor times the concentration conversion coefficient times a unit of conversion and divided by the sample size in grams. Let's go through each one of these, shall we?
Yeah.
So the EP1, that's what the titrator is going to spit out. That's what's dispensed by the titrator, and we're generally looking for about 1 mil, right? Is that about right, Charlie?
A minimum of 1 mil.
Okay. Minimum of 1
to get the best data. Yeah.
Okay. And for you out there watching, I think you can resize the size of the presentation on your console and make it pretty big. You might be able to pick up the numbers over there on the right side. Okay, so let's go to the next one. The blank, BL1, blank level. And you see here, it's 0.0037 milliliters. And so what is that? Well, we do a blank on the titration solvent. And how much of the base or acid is in that solvent is what we're doing. We're basically identifying how much is in that solvent, because we're going to be putting our sample into this solvent when we do the titration. So that's what that's all about, right? Backing it out. Okay, TF, factor of the titrant, 0.09483 is generally around about 0.1, I guess.
0.1, right.
Yeah. Typical if you buy or make or need to, if you buy or make it yourself, it's needed to neutralize the base. The method basically calls for it. So that's what the titrant factor is all about. C1, concentration coefficient, conversion coefficient, 56.11 milligrams per milliliter. This is the KOH. And so what this is, it's the sum of the atomic weights of the KOH, and that's composed of, let's see, potassium, and that's 39.1 is the atomic weight of potassium. Mm-hmm. Oxygen is 16, so 39.1, I think it's 39.11 actually, plus 16, and then plus the hydrogen is 1. So you add those three up and you get 56.11 milligrams per milliliter for your KOH. So it's not a number that's out of nowhere, right? Okay. Okay, next, K1, the unit conversion coefficient. I think this is just like in a computer program. You can't have 0 because you have to multiply times 1. So I think that keeps the multiplication.
And that one will give you the whether you want the result in milligrams per gram.
Right.
It would be 1. If you wanted it part per million, it would be 1,000.
Right.
If you wanted it weight percent, it would be 0.1. So,
Got it. Got it. Good. Okay. And that leaves us with sample size G, so in grams. And I guess generally speaking, about 1 gram, that's the target roughly, I guess, for the sample size.
yeah, there's a guide, there's a table in the methods that give you the suggested sample size based on the expected base number. So.
Okay, got it. When we're doing this calculation based on the sample size that we just talked about, using these general numbers, we're generally looking for an answer of around 10, right? 10 milligrams per KOH per gram, right?
Yes, that's typical.
Yeah, and so the beauty of knowing the calculation is that after you run it on your titrator, you can actually just take this formula. You'll have all these numbers. You know what the titer that was spit out by the titrator, and you can plug it all in, and you can hand calculate the answer yourself. If you just take those numbers that we have here and you use the first, there's 3 sample tests there, but if you take the first numbers, you would calculate out to 9.19 by hand. I did it, and it works. So it's a great way for you just to kind of, get your mind around it and say, yeah, I understand why the titrator is getting the answer. I can do it by hand. It works. So it's a good thing to get. It's a good habit to get into.
Yeah, and it goes for just about any titration.
Yeah, that's true.
Not just limited to this. It's a general equation.
Yeah. Well, if you think about it, titrators, were not the first thing around. Titration occurred before titrators, right? So
sure.
we were doing it by hand before then. So that leaves us with this graph. Charlie, can you walk us through the graph and tell us about these squiggly lines that we have on the graph there?
Well, that first curve that has the dot in the middle, that's a plot of the milliliters added versus the millivolts response. So the titrator adds, based on that, based on the response it gets, it adds more titrant until it starts seeing a greater increase in the millivolt. And as it gets near the equivalence point, for a very small amount of titrant, you get a large millivolt potential difference. So what we're looking for there is where the curve changes direction, or right in the center of that S-shaped curve. The titrator uses the data points and takes a first derivative, and that curve on the bottom is the first derivative curve, and where it comes to a peak, that's where the titrator calls the endpoint. So it does it mathematically, but you can do it graphically too by looking, pretty much by looking at it. So
that's great. Yep. That's great. Good explanation. Thank you for that, Charlie. That's great. All right, let's. So we talked about the calculation method. So let's talk about what's involved in doing the titration. So we're going to talk about some things like titrants, reagents, supplies that are required for each of these. Side by side, I've got both up here, both of the methods. And so the D2896-21, if you look at that, has 2 reagents and 1 solvent. Whereas D4739-17 has 1 reagent and 1 solvent, okay? So we're going to explain why as we go through this. But anyway, let's just talk about what they are for the moment, okay? So for D2896-21, we have 2 reagents that we're going to be working with. Perchloric acid, acetic acid solution. Say that 3 times. Perchloric acid, acetic acid solution.
Careful.
Okay. Sodium acetate. Okay, I have back titration. Yes, that's what's going on. We've got two reagents, so we're going to need 2 burettes when we're running the D2896-21. And then we have a titration solvent of acetic acid and chlorobenzene with a 1-to-2 ratio when you mix it up. So that's what's going on with the D2896-21. The D4739-17, 1 reagent, that's HCl and isopropyl alcohol, otherwise known as IPA. And then our titration solvent, I go into a little bit of discussion. You measure Charlie, I took these notes from you. You measure 5 mils of deionized water and approximately 495 mils of anhydrous propanol to all and mix well. Add approximately 500 milliliters of anhydrous toluene to the jug and mix.
Yeah, that's they add the water just so it will conduct electricity.
Okay.
When you have the anhydrous chemicals, they don't conduct so well.
Okay. And so when we talk about solvents, Charlie, we pre-make these solvents, right? We mix them into a jug. We've got them. So when we go to run our titrations, we'll have them available. Is that right?
Yeah, most everyone uses the I guess the certified titrants.
Yeah.
So the method outlines how to make it, but you have to standardize it, and it's quite a process. So it's simpler just to buy them.
Okay.
But you would need to monitor them, once in a while, run a check to see that the titrant is still holding up at point 0.1 or so.
Okay. Okay. So you can make it though, right? You can make it or buy it, but if you make it, you make a batch of it. You don't just make one for one run. You make a big batch and you hope to use it for a week or so, right? 2 weeks or whatever.
Oh yeah, at least.
Right. Okay. Okay. So that's we're going to need that for our reagents. We're going to need that for our solvents. Again, the solvents is what we put our sample into when we get ready to run the titration. Okay. So let's go to our next slide here. What's next? Required electrodes. For both methods, I have C171/C173. That's particular to a brand or a model, but at the end of the day, it's a combined pH electrode. And the 173 is for non-aqueous samples. The C171 is for your aqueous samples. But there is a difference. So you can use the same electrode for either one of these methods. However, you have to change the inner filling solution on the ASTM D289621 with sodium perchlorate and acetic acid. Whereas for the ASTM 473917, you're going to change it out and it's going to be lithium chloride in alcohol. So they have a different inner solution. So with that, you just have to know that, yeah, I've got the same electrode, but they're not the same because I'm changing out the inner solution. I will point out that if you're running total acid number, ASTM D664 TAN, and you're running 4739-17, that electrode setup is the same for TAN. So you could run TAN and 4739-17 on the same titrator. You'd have to have a different burette for your titrant, but you'd have the right electrode, right?
Right.
Cool. Temperature compensation electrode, pretty standard fare on both of those. So that's what we need for electrodes. So I hope that was fairly straightforward on that. Let's go into our next slide, shall we? All right, procedure for running the method, side by side again, 2896 and 4739. We're going to run a blank test for both, right? And we're going to run a measurement, right? So, Charlie, I know we took some things from the methods, and these amounts, I don't know if those are particular to a specific method, but for the blank on the 2896, we're running 120 milliliters, is that right, of solvent? And
for the procedure A, which would be your normal. The procedure B is so you can use an auto sampler.
And so you use like 60 mils, I think you said, right?
Right. You have to cut it in half.
Okay, got it. All right, so in that particular case, the blank test, and then you titrate with 1 mole of perchloric acid, acidic acid solution to measure a blank level. That's that 0.0037 that we talked about, I think, before. And then when we go to the measurement, we're going to weigh out X grams. I keep saying X grams, Charlie, but I think you keep saying something about the appropriate amount, right?
Appropriate amount according to the table in the method. Because there again, they're trying to get, if the TBN is low, you need more sample. in
Okay.
order to get it to register. If it's really high, you need less sample. So,
Okay. Okay. Um, so there's a subtlety here on this slide, by the way. And so on the measurement for the ASTM 2896-21-21, after you weigh out the amount of sample and you add the 120 mils of solvent, you're going to titrate. The titrate is going to add 8 mils of the perchloric acid titrant. Then it's going to back titrate with the sodium acetate solution. So that's where the two reagents are working together on that particular method. So it's a back titration. The titrator will have two burettes. It's either going to have two onboard burettes or it's going to have a burette and an APB dosing the sodium acetate solution. So just know that the configuration setup, and I think that I was kind of building towards that. I don't know if I really nailed it, but that particular method is more involved. It requires two burettes, two reagents. It's doing a little bit more, and we're going to talk about what that is. Whereas for the ASTM D4739-17, 120 mils of titration solvent, same issue with the solvent, and we're going to titrate 1 mole of HCl in IPA solution to get the blank. And then we're just simply going to do the titration. We're going to weigh out the appropriate amount, and then we're going to titrate 1 mole of HCl in IPA solution to measure the TBN. So it's a little more straightforward, I guess. Would you say it's more straightforward, or simple, I think?
yeah, I think so.
Okay. Okay. So again, 4739-17 has one burette because you only have one titrant, whereas with ASTM 2896-21, you have two reagents, and you're going to have to titrate both, so you're going to have two burettes for that setup. So I think that's good. Okay, let's go ahead and let's jump to, let's see, I think, yeah, we covered all of that. That's good. Okay, let's go to our next slide here. Tips for running TBN. A lot of this is about the electrode, okay? But there's a couple comments in here that I think are good to talk about. But first thing, do not, leave the electrode immersed in titration solvent. You got to keep the health of the electrode in shape between tests because that's usually where things kind of go bad. I don't think we put on here either, Charlie, you want to make sure that interfilling solution is always filled and not down to the bottom.
Yeah. One way you can tell your electrode is becoming desensitized or your curve will be flattened out. Right. So you won't see the sharp S in it. So yeah, if you run them back to back, it's going to dehydrate the pH electrode and reduce the sensitivity of it.
All right. Okay. Good information. Let's see what else. Handle reagents in well-ventilated room. If you have to regenerate the sensitivity, let's see what you say. Wash your electrode in titration solvent and immerse in pH 4 buffer. Okay, you talked about that. We talked about preferred to run a TBN standard daily. I'll say that again. It is preferred to run a TBN standard daily. It really is. I'm not saying that because it's on the quiz, but it might be. Okay. When the glass electrode is contaminated, you want to clean it in a solution, and it could be cold chromic acid or some alternative cleaning solution. So
yeah,
really,
they have some alternatives.
Yeah. So that's a big one. I think the electrodes are underestimated. I think they sit there, and if they're not taken care of, they're gonna be your worst enemy. So got to keep that going. That's the last two, Charlie. Can you talk about these? These are, I don't know if these are specific to ASTM 2896-21, but standardizing the perchloric acid solution. That goes really. That's true of any solvent, right? We're going to standardize them, right?
Any of your titrants, you'll want to run a titrant check. Every once in a while, depending on how quickly they degrade. Then probably once a week is okay.
Okay.
For the perchloric acid.
Okay.
And same for the the HCl and IPA.
Okay. Okay. So those little things matter, right? I mean,
Yeah,
that's
titration it's a lot of little things that add up. So
right. Right. That's for sure. That is for sure.
a lot of
I couldn't agree more. I think it is important. Well, let's just kind of roll through that. Those are some tips. Let's go to our next. So we're going to jump into some pros and cons. Let's talk about it. For ASTM 2896, we talked about there's 2 burettes. There are 2 reagents. It's this is basically used for monitoring new oil additive packages because it's got stronger titrant, perchloric acid, and a more polar solvent, the chlorobenzene. And a note here, it says, I got to repeat this. It dissolves and reacts with all sources of base number, detergent, dispersants, and antioxidant additives. So it's basically looking for all of those, in other words. So
right.
That's what that method's good for. It's covering the whole field of things that it needs to cover for the base number. A more complete picture, as we mentioned here, and it's got some pretty good repeatable results because it's hitting on all cylinders, if you might say. So, definitely, it is preferred for new oil additive packages for those reasons. Some of the cons. And I don't really understand why it's always going to be higher, but is that because it's seeing everything, Charlie? Is that why it's going to be higher?
It's thorough. It's a stronger acid, and it's a stronger solvent. It's going to break more bonds.
Okay.
And it's just they'll usually use the 2896 for setting the specification. So that's the test you'd run to set the spec. And the test you'd run on new oils. Now, when you get to, the used oils or in the oil servicing program, you want to go with the 4739.
Okay. Yeah. I think, and to add to that, I think you're right. But one of the cons that you didn't mention was health concerns because of the perchloric acid. I guess that's
right. And from both of them, the perchloric is kind of nasty stuff too. Even though it's at 0.1 normal, it's enough.
Okay. Any stories about that you want to tell us? I don't know if there's any good stories.
I've heard that it'll form, explosive mixture if it dries.
Really?
I've never seen that, but it is very unstable being having a lot of chlorines hanging off there.
Wow.
So
all right. Good to know.
I don't want to test. I really don't want to test it. So
yeah. I don't want to test that one either. I don't want to push that. I don't want to find out. All right. Let's talk about ASTM 4739. I'm leaving off the dash here, but pros. It's good for used in-service oils. Because the titrant is the hydrochloric acid, and it's only going to titrate, I guess, the detergent additives. Is that the idea? It's just really going after, not going after everything, just going after detergent additives, it looks like.
Right.
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 Okay, so I'll say it again because I'm not saying it's on the quiz, but it's more commonly used for oil testing laboratories for in-service oil monitoring programs. So best for monitoring additive package depletion over time. So that's the pro for ASTM 4739. I guess the con is that it can, what do you say here? It gives lower results. And I guess that just goes with saying that it's only measuring the detergent additives. So it's going to have a propensity to undersee what's really going on in the oil. Right. Okay.
Yes.
All right. Okay, gosh, we're moving along here, folks. So let's just go right into our next slide here. The takeaway. ASTM 2896 determines all basic species. Should only, I don't know if only be used, but should be used for characterizing specifications for new oils. And ASTM 4739 determines only the detergent additives and should be run for used oils or for in-service oil monitoring programs. So, all right. So that takes us to a point where I'd like to see if we can. We have 12 questions, 12 quiz questions. So let's see if we can just go through these.
A quiz. Yes.
Let's have a quiz. Let's do a quiz. Okay. So let's. It's self-graded. So we'll give. We do have the answers, and we'll be happy to tell you what they are. But first question. For ASTM 2896, the interfilling solution for the C173 combined pH electrode used in this test is acetic acid, methanol, lithium chloride in ethanol, or sodium chlorate in acidic, I can't say that, acid. We'll give you guys a few more 15 more seconds to answer, and we're gonna reveal the results here, right?
Right.
That's right. All right, we're doing.
Can I give them a? Yeah, no hints. No hints.
No hints? Well, you can give them a hint.
For the next one, maybe.
Okay, all right. Here we go. Let's see. 44% lithium chloride in ethanol and 55.6% in sodium perchlorate in acetic acid. Well, I think, what do we say that is? What is the right answer for that one there, Charlie?
Well, I'm gonna go with the sodium perchlorate in acetic acid.
Yeah, that's the right answer. That is the right answer.
Match the perks.
That's right. That's the correct answer. The correct answer is sodium perchlorate in acetic acid. I think those of you who chose lithium chloride and ethanol were confusing that with ASTM 4739. Oops. Okay. Well, let's go to our next question.
Yeah.
How often did you run a TBN standard? Daily, weekly, before every sample run, or never? Give everybody about 30 seconds here.
Yep.
Okay, here we go. Here we go, folks. Get your answers in, because the answer is daily. They picked up on that.
All right. Somebody's awake out there.
Yes, sir. That was one of the tips that was one of the tips for titration. I like it. That's the right answer. Okay. Next question.
You can totally extend that to just about any test.
Right. All right. Functionally, how is ASTM D2896 run differently than ASTM 4739? Two methods are identical. ASTM 2896 involves a back titration. ASTM D2896 uses only one titrant, or D, none of the above. Give you about 20 seconds to answer this question. ASTM 2896. That's a good one. That's a good one. I'll wait 20 seconds. I don't know. Looking at my clock here. Okay. All right. I think this is an easy one. So let's go ahead and see what happens here. There it is. ASTM 2896 involves a back titration. I guess we got that through. They understood that. Yes. You know, the way I remember it too is ASTM D2896 2, D2896, the 2, I think 2 titrants, right?
Yeah, there you go.
Even though ASTM 4739, there's no such, I don't have 4 titrants, but that's how I remember that one. That's how I discern them. So great. Okay. Next question. Do you run blanks on the TBN titrations? Yes or no? We'll give you guys about 10 seconds to answer that, because this is not too. It's one or the other. Okay, about 5 seconds here. Okay. All right, here is the answer. Oh, look at that. Everybody got that right. That's correct. We run blanks because we talked about it.
Whether you do or not, you ought to.
Yeah, that is a great point. You should run blanks.
And
right.
And you don't have to run it with every sample or even every day.
Right.
But if you open a new bottle of titration solvent,
yeah,
run your blank.
That's
maybe
right.
2 or 3 times, and and hold that average
Got
for
it.
as long as you have that batch. So.
Got it. Good stuff. All right, next question. TBN ASTM 2896 is preferred method for A, used oils, B, new oils, C, waste oils, and D, baby oils.
Baby oil.
Baby oils. Okay. This is pretty straightforward, but let's see what people are paying attention today, Charlie. We'll see.
So
The ASTM D2896. I'll give you about 5 more seconds here. We pounded this pretty hard. I can't imagine somebody picking the wrong one, but you never know. Okay. All right, here we go, folks. Here it is. Oh, we got used oils 33.3% and new oils 66.7%. So, well, the answer is we said
new.
We said new oils. Remember?
Yes, we did.
I think we tripped them up with the in-service oils / used oils, but I don't know if that's true. But new oils is the right answer. At least it is for this quiz. Okay.
Yeah.
All right. Let's go on to our next question. TBN ASTM D4739 is the preferred method for A, in-service oils and used oils, B, new oils, C, waste oils, and D, baby oils. Okay, this ought to be pretty easy. I mean, based off that last question, right? ASTM D4739 is the preferred method for A, B, C, or D. Okay. We're still at it. We're watching here. I'm watching. I can see when people are answering the question, so I can see it's rattling up. So I'm going to give it a few more seconds here. Come on. I know there's some more out there who want to answer this question. Just go ahead. Take a guess. Okay, that's good. I saw some.
That's a good guess.
Okay. All right. Okay. All right. Here we go. Let's go to our answer. 100% in-service oils and used oils. That is correct. Folks, we only have a few more questions, so stick with us, okay? Okay, that is the correct answer. ASTM D4739 is for in-service oils and used oils. Good answer. Next question. Why are lube oils treated with alkaline additive packages? A, to allow oil to flow better. B, to protect the oils from degradation from acidic compounds. C, to increase price value of oil sales. Or D, none of the above. Why are they treated with alkaline additive packages? Come on. I know you're out there. Come on.
You can do it.
Give it some more time here. What do you think it is? What do you think it is? Treated with alkaline additive packages. Come on, let's get a few more answers in here. I can see the answers rolling in. Doing well. We're doing well. Okay.
United States Shoki.
Okay, let's see. 13 of 17 right now.
United States Shoki.
And let's see here. Okay, let's go ahead. Here we go. 92% picked to protect the oils from degradation and from acidic compounds. And that is correct. That is the correct answer. Degradation from acidic compounds. That's what this whole thing was about. The degradation of the oil over these compounds, right? Right? I don't know how to say it any differently, right?
That's
Good
it.
answer. Okay.
Yeah.
All right. We're almost there, folks. Almost to the end. How do acidic compounds become present in lube oils in service? Well, A, they are added to the manufacturer by the manufacturer. B, they form as a result of oxidation and thermal stress. They were present in the oil to begin with, or D, none of the above. How do the acidic compounds become present in lube oils? How does it happen? Come on. I know we can get some people to answer this one. Okay, we're getting some responses here. Wait a few more. We got some responses coming in. We'll give them another 10 seconds or so. 15 seconds. Okay. Keep coming. I can see you responding. We have people responding right now. Okay. All right. So let's go ahead and see what we have for the right answer, shall we? Okay, here we go. All right. The answer is they form as a result of oxidation and thermal stress. That is the correct answer. 92.3% of you got the right answer. It's added by the manufacturer. That's not the right answer. But if you got result of oxidation and thermal stress, you got it. Okay. Next question. What three types of additives contribute to reserve alkalinity and lube oil product of a lube oil product? Detergents, viscosity improvers, or antioxidants? I talked about this a lot, you guys. B, detergents, antistatic agents, and viscosity improvers. C, detergents, dispersants, and antioxidants. And D, none of the above. I mentioned this probably 4 or 5 times. What three types of additives contribute to the reserve alkalinity of a lube oil product? I know we can get this. I know we can. I think we only have about 3 more questions after this question, so we're almost home free. 3 types of additives contribute to the reserve alkalinity of a lube oil product. Come on, guys. I know you can do it. Please answer them. Yes, we got them rolling in. I can see them. I love it. Okay. So a few more respondents, and we're going to reveal the answer. Okay, we're just about there. Okay, I'm going to give it 1 more second to, there we go. Okay, the answer is detergents, dispersants, and antioxidants. That's correct. 76.9% of you were correct. 23.1 were wrong. Viscosity improvers was not on the list. So that's what tripped you up on that one, I think. So, okay. Next question. What titrants are used for TBN ASTM D2896? And I will say, if this was set up correctly, this is multi-select. So you can pick more than one. So what titrant or titrants are used for TBN ASTM 2896? KOH and IPA, HCl and IPA, HClO4 and acetic acid, and D, sodium acetate and acetic acid. Okay, come on. We only have 2 more questions after this, guys and girls. We can do this. Okay, we're getting some responses now. I can see it real time. Real time responses right now. Okay, come on. Okay, they're coming in. All right, I like it. Okay, people are answering. I guess there could be a delay on the internet, so I have to give it a few seconds, you know. It seems like it rolls. They start coming in. Okay, let's see what we're going to get here. I actually don't know what to expect on this one. Okay, come on, answer here. One more. Okay, all right, let's go. All right, here we go. KOH and IPA is wrong. HCl and IPA is wrong. HClO4 and acetic acid, that is correct. And sodium acetate and acetic acid, that is correct. They're both correct, right? You need both.
Yes.
Yes. So, you know, remember we talked about ASTM 2896 having 2. There was 2 reagents. There's a back titration, right? So we're going to use the HClO4 and acetic acid. Titrate is going to, what, titrate 8 mils or something like that? And then we're going to do
it's excess titrate in And
And then we're going to get back titration with sodium acetate and acetic solution. That's our acid. That's how we get that one done, right? Two burettes, 2 titrates. So
yes.
if you didn't get both, we'll have a review next week. Okay, next question. What titrates are used for ASTM 4739? KOH and IPA, HCl and IPA, HClO4 and acetic acid, and D, sodium acetate and acetic acid. This should be pretty easy. This should be pretty. One more question after this one, folks, and we will have finished. One more question after this one. What is the titrant that you're using for ASTM D4739? One more, come on. We're getting some responses now. We want to make sure we're using the right titrants when we do ASTM 4739, right?
Definitely.
Yeah, that would not be good if we didn't. Okay, we're getting some responses. Come on. Okay. Okay, I think we got some responses here. Let's go ahead and see what we have here. Okay. Whoa, we're all over the board here, folks. The correct answer is HCl and IPA. So 45.5% of you were correct. Everything else is wrong. The bottom two, the HClO4 and acetic acid and sodium acetate and acetic acid is for the 2896. It was right. And the KOH and IPA is not the answer. So it is HCl and IPA. Okay. Last question, I think this is correct. TBN ASTM 4739, the inner filling solution for this C173 combination combined pH electrode used in the test is acetic acid, methanol, lithium chloride and ethanol, or sodium perchlorate and acetic acid. Remember, I said this is the same inner solution for tan.
Yeah.
So,
your hand is tan.
yeah, it's a little hint. So this is the last question, folks. What is the inner filling solution for the combined pH electrode when you're running 4739, which happens to also be the same electrode and the same inner filling solution when you're running tan? We talked about this. I'll give you a hint. It's used in batteries. Maybe that was too big.
Yeah. Batteries that burn.
Yeah. Right. All right, we got some responses. Come on, let's do it. We're almost done, folks. Hang in there. Okay, I'm going to go ahead and take us to the answer. And the answer is lithium chloride and ethanol, 72.7%. That's correct. Acetic acid is not correct. And sodium perchlorate and acid is not correct. So lithium chloride and ethanol, there's your answer. So, folks, that is the end of the quiz. I will say thank you. Make sure to download the presentation. You can do it from your console. Again, this webinar is on demand, so if you couldn't watch the whole thing or you got distracted, you can go back and watch it. You can take the quiz or watch the quiz, and you can self-check yourself. I have the quiz in the presentation, so you can download the presentation with the quiz questions, and you'll have those on hand. You can also email us if you watch the webinar at a later time, and we will respond to you with answers. And of course, if you have any questions, please email us or call us. We hope this webinar has been helpful. It's a common, application, right, Charlie? It's either some basic things, but we're just glad to share it and talk about it, right?
Yes.
Yeah.
And it eliminates some confusion between the two tests. So.
Yeah. Again, why do you do both? It's because probably the specification asks for it, and that's a good enough answer. But you got to know how they're different and how to apply them. So, again, if you have any questions, please let us know. We're really happy. We're going to do some other interesting applications, including bromine. I think that's our next one, Charlie. Right?
Yep.
Bromine.
Yep.
Yeah. So, anyway, thank you very much. I'm going to go ahead and end this broadcast. And thanks again for attending. And we will see you soon. Thank you.
Adios.